All right, CIS255 database. This will be the Modern Database Management Chapter 4 slide deck, all 54 slides. I may have to split this video into two separate recordings. That was my plan initially, right? So if you look down here at my view of Canvas, just posted Chapter 3 a little bit earlier tonight. Deck 4 is scheduled for week 2, and then finish Deck 4. Yes, so many slides. But at some point, okay, I want to get you folks signed into Azure Labs. So I know this is out of order, but if you haven't yet seen week 1, I added 3 new items earlier today. The PDF instructions for creating an Outlook email address. Now, it doesn't have to be Outlook. If you have a Yahoo, a Hotmail, whatever, that is sufficient. But what I want you to do anyway, I want you to look at these instructions. I want you to follow these instructions. Okay? In a previous video, I had said that you putting your subject line like this means that 12 weeks from now, when I have students say to me, hey, how come I have a 0 for such and such assignment? Right? A standard naming convention can help me find your email. Okay? So even if you're not going to use Outlook for your new email, that's fine. I have a Yahoo account that works perfectly well. Just from that account, send me an email with this subject line, right? The body of the email, you know, call me whatever names you want, you know, whatever, just so the subject is what it is. Okay? So we'll get this deck posted here, and we'll go from there. Okay, so let's see how far I can get. 55 slides. Good God. That hurts my soul. So we're not going to finish this deck, not in one video, because this conversation can take an hour, at least an hour. Okay? I think that it's important, though, that we talk about normalization, because even entry-level DBAs have to have an understanding of first, second, and third. Heck, they go all the way up to sixth, right? And normal forms are denoted this way. Oh, get out of here. What the heck? I don't know why PowerPoint does that on some slides. Okay, the number 1, the letter N as in November, the letter F as in Foxtrot, 1NF, 2NF, etc. Okay, so once we get through the rigmarole of creating your ER diagram, we've got to start converting that diagram into our actual structure. We're going to need tables of data. Those tables of data are going to contain rows of information and fields or column names. Okay, these will be your attributes. These will be your entities. Now, do remember, the ER diagram does not have to match one-to-one. Table names, column names. Okay, so we'll start talking about DML and DDL, data definition language and data manipulation language, as it relates, right? Structured query language is actually a language. Okay? Microsoft has their own SQL, right, or SQL, depending on who you ask. So does Oracle. Okay? SQL, pretty specifically, is a programming language, more so than it is a database management engine. Okay? But if I'm talking about DBMSs specifically, I'll say Microsoft SQL or Oracle, etc. Okay, we'll talk about something called referential integrity. Okay, we'll start touching on that maybe in this half of the deck, maybe a little later. Okay, lots of terms and definitions in this class. A relation is a table. Technically, all relations are tables, but not all tables are relations. There are some tables that will store query results temporarily, right? They're technically not relations, but that's okay. Think of a relation or a table like you would think of a spreadsheet. Rows and columns and cells where there are intersections of rows and columns. Okay. These rules, I'm going to point them out to you because they're here on the slide. I'm not going to test you, right? Again, this is an entry-level database class, and this is, I think, a little too deep into the weeds for a 100-level class, okay? So don't worry about the requirements necessary for a table to equal a relation. I do want you to know this, okay? Tables do have to have unique names. I cannot have two tables with the same name in the same database. Two different databases that each have the same table name, that's perfectly fine. Okay. As it relates to our class, attributes, the fields in a table, can be atomic or static, singular static values. They can also be multi-valued. Okay, an attribute in our database might be street address, house number, street name, city, state, zip code. That's actually a multi-valued attribute. Well, actually, that's a composite attribute. Phone number is more multi-valued, right? Because some people have cell phones and house phones or landlines. Okay, so for us in a database, I can have static, multi-valued, composite attributes. I can also have derived, okay, let's say derived fields. Okay, I can, with your date of birth, run a query to tell me how old you are. Okay, obviously, as it relates to databases, I can't have two rows with exactly the same data. Now, that's an important distinction. Okay, you can have two Michael Kellys in your database, but you have to have a primary key field which uniquely identifies each of us. Okay, so you might have a customer number, or as an L-Tri-C student, you have an L number. Okay. Attribute names have to have unique names. Now, I can have student table, professor table, and I can have first name and last name fields in each table. But in the students table, I can't have two first names. Okay, now, I do hope that these things are, thank you, Captain Obvious-esque. To the point where I didn't really need to spend the last 3 minutes on this slide, but here we are. This bullet is going to become important once we focus on normal forms. Okay? There are a set of rules that have to be followed for a database to be considered normalized, and again, we're going to get there. I do want you to, because depending on who you work with, they're going to call them tables, they're going to call them relations. Relations are not the same as relationships. Okay? A relation is a table that follows the rules on the last slide. A relationship are how two relations, or more than two relations, relate to one another. Okay? So we've got primary keys, foreign keys, composite keys, candidate keys. Okay, we're going to talk about all of those things moving forward. The primary thing I want you to remember about primary keys, in the table you're looking at, your customer number, your L number, that is how I uniquely identify every record in the table. Okay. Once we start building multiple tables and relating them, we're going to start making use of foreign keys. So you as a student right? As a full-time L-Tri-C student, I believe you're required to take 12 credits, 4 classes, if each class is 3 credits each. Your student table will only have you listed once, even though you're taking 4 classes. Your courses table will have every course that L-Tri-C offers listed only once. And we can relate the L number in the student table to multiple course numbers in the courses table, right? Foreign keys in this case would be the course numbers. Okay. So here is what an EER, an enhanced entity relationship diagram, looks like for 4 relations. Now, this is probably as deep as we're going to get as it relates to table and field layouts. This is an important rule for you to follow. Primary key field, always underlined. In your ER diagram, relation names always singular, always all caps. Now, there's no Microsoft or Oracle SQL rule that says, do this or epic fail. But it is considered best practice, and your more experienced DBA brothers and sisters are going to look upon you negatively if you don't follow that rule. Okay. Attribute names or field names should also be singular. They can be any case you like. Now, queries that we write are case insensitive. So I've got a customer table, a customer relationship listed here. If I write a query to select customer ID from customer, I can write it in all lowercase. Lowercase c, capital USTOMER. Case insensitive, doesn't matter what the case is. Okay. Primary key, right? So I'm just going to write the letter P here instead of PK, only because you know that my handwriting here is pretty crappy. Foreign key. The order table, wait, what? I thought you said table names have to be unique, but I can have a customer ID field in 100 tables if I want. This is an easy way to relate the customer table to the order table. You go to Amazon and you look at your order history. How do you think that order history is returned to you? One customer can have 0 or more orders. So you'd write a query that would read something along the lines of select customer ID from customer where order dot customer ID equals customer dot customer ID. And you would be able to bring up a list of all the orders placed by that customer because I'm relating the primary key here to the foreign key here. Okay. Want to see the individual line items? Okay, I can relate these 2 tables together. Okay, want to get information about the products you ordered previously? I can relate these 2 items together. Okay, now we're going to come back. Maybe you'll have questions about the way that this slide is written and the fact that I've got a composite key here. So let me answer that question since it just came to me. It should be impossible for there to be more than one order with the same ID, right? If my order is number 1 and you place an order next, your order will be number 2. But I can order 10 things in order number 1. So my order ID is unique. but my order line can contain the 10 items I bought. However, it should be impossible for my line items. I shouldn't have the same product ID on the same order number, right? So if I order widget ID 123, order number 1, and then I go back later and say, I need 10 more widget 123 in the same order, it's just going to add them together. There won't be a second line item, right? If that makes sense. Okay, so we've got constraints to worry about when we're taking our ER diagram and turning it into an actual actionable database. Okay? Domain constraints. Simply stated, I can't put dates in a text field. Okay, something like that. Okay, I can't use null values. Okay, entity integrity for primary keys. Now, a null value is separate from me typing the number 0 in a field. Okay, the number 0 is an actual value. Null means that the field is blank, it's empty. That is an important distinction. Okay? Primary key fields. And there might be some other fields that aren't primary keys that can't contain null values. Okay? If my order line items contains a unit cost. Now I'll just type the letter U and the $sign here. I'm ordering 10 widget 123 items. Okay, so widget 123 is my product ID. I'm sorry, my order ID is 1. My product ID is 10. Let me clear I draw on these slides and then it looks terrible. So my order ID is number 1. I'm the first customer to place an order. I'm going to buy widget 123 as my part number. I'm going to buy 10 of them. These widgets that I'm buying each have a unit cost, a unit price. Whatever the unit price is, let's just say it's $5. This unit cost field is not the primary key, but it cannot be null. Even if I'm buying one and getting one free, even if this is some kind of promo where you're giving me widget 123 for free, the unit cost would be 0, not null. Okay, so null values can be applied to fields other than the primary key. Referential integrity. We're going to come back to this in a little bit, but simply stated, let me see if I can explain this without the assistance of a graphic. Let's say that through poor database design, we put all our data in one table. And let's say that one student registers for Mike Kelly's CIS255 class. So your L number, course number CIS255, professor is Mike Kelly. You change your mind. You drop out of that class or you withdraw. So you are able to cancel your registration for that class. What happens to my data in that table? Deleting your registration, you the only student registering for this class, is going to delete my name and course number CIS255 from the table. That violates referential integrity, and that is one of the reasons why relational database management is so important. We would not put all our data in one table. We would split students from courses, from professors, and we would relate them. Okay, I cannot, with referential integrity, then delete something from one table without it breaking the other tables. Okay, so more details to follow. Sorry, I wish I could shake this cough. Okay, so because we have some tables that are dependent upon other tables, it's critically important that we, the DBAs, control how data is to be deleted. Referential integrity, they're rules that prevent data from being deleted when there is other data dependent upon it. Okay, so for example, right, your student record, my professor record rather, wouldn't get deleted if you, the only student in my class, unregistered for that class. Customers' information won't be deleted from the database if another table contains orders that that customer has placed previously. You can't delete the customer, right? Obviously, if there is order information for that customer in the database. Okay, so think of them as delete rules. Okay, so we'll look at some SQL code here in the next week or so where we talk about Cascade is the most frequent that I've seen, but you can also choose restrict rules or set to null rules. Okay, and we'll talk about weak entities. I think I made mention of them previously, but we'll talk about them later. So we've got these ER diagrams, and now we're starting to build them. We're starting to build out our databases. Part of our ER diagram, though, has to contain referential integrity constraints. Okay? We draw these arrows here between the foreign key and the primary key. Okay? This is one of the ways that we will depict referential integrity constraints. If there are previous orders in the database for customer ID 12, I can't go in and delete customer ID 12. You just can't. Okay? And anywhere that you see, and it doesn't have to be a squiggly line like this, right? This order ID relates to this order ID. Okay? So we'll see some examples of this. Okay? Now, this is slide number 11. We're going to spend a little bit of time on table creation. Mostly what we're going to do, though, is we're going to look at tables, table spaces, and relations that are already created, and we'll draw some queries from them. Okay? But if you take a look at, even if you don't know how to code in SQL, structured query language, if I would present you with something like this, you should be able to follow the logic. Okay? So we are, first things first though, we're defining a table, but we need a table space up here first. So that's something I'll show you later, right? When we actually are doing hands-on. Okay? So we have to create a table space, which is actually the database itself. And then inside that table space, we're going to create a table called customer T, order T. Now, some DBAs will use _T for tables, _Q for queries, _R for reports. Okay, there are also triggers, okay, stored procedures, and other things like that. My suggestion is at your place of work, follow the standard convention that they're using. Hopefully they're using a standard convention. I wouldn't bet my life on it, but you can always hope. So we are creating a table, and we're going to name it this. We are going to create field names or attribute names. And again, these names can match your ER diagram. They don't have to. We're specifying a type, a data type, 11 digits, no decimal places for the customer ID. Your customer ID can be, and you should seriously consider, using the character or variable character data type. Numbers can chop off the leading zeros. Variable character length of 25 here, that's what this number 25 means that leading zeros will be kept. I can't specify, obviously, no decimal places for character data types. You'll get a type mismatch error if you try that. But here's a good rule for you to follow. Do you plan on doing math with this field? And if the answer is no, then characters are fine. Okay. Character data type, okay, generally used for shorter fields. Variable character 2 or varchar 2, generally used for longer strings. I have some constraints right here telling me that customer ID and customer name cannot be null. These other fields are optional, but these two fields absolutely mandatory. I wish I understood why PowerPoint did this, but only on certain slides. See, it's not drawing that anyway. It surprises me every time it does it, but anyway. We're going to define a primary key through the SQL command line interface, or CLI, this way. Okay. Our customer table's primary key is the customer ID field. Okay. Following the syntax, okay. Now, the one other thing I'm going to point out here, right? We're going to end up relating these tables to each other. Foreign key, customer ID, references the customer ID field in the customer's table. This is how I can write a query that will join these two tables. And we'll talk about inner joins, outer joins, etc. Later on. Okay. But my hope is, right, even though I've only spent maybe 3 minutes on this slide, that you can look at the text that's given to you and follow the logic. So, 7 consecutive slides of how to do this. Okay? Do not just sit down and start typing away. You're going to end up with terrible database design. Someone else is going to have to come along and clean up your mess. This is not a good way to engender feelings of goodwill with your fellow DBAs. This is not a good way to gain trust from your manager. Okay? You should always plan out, whether it's a program you're writing or a database you're designing. You should have a logical, conceptual model of what you want your data to look like. And only then should you take those pieces of paper, whether they're actual paper or electronically designed, like through Lucidchart, and throw them into actual database tables. Okay. In fact, I can guarantee you, you're going to bugger this up if you don't follow these instructions. Okay. Regular entity types. The customer entity type. This is what it looks like in the ER diagram. This is what the relation looks like in the actual database. Now, I don't necessarily know that I would use long field names like that. Long names in your ER diagrams, fine, because your ER diagrams might be read over by folks who help you design business rules, but may not understand the nuances of the technology used to make the database. Okay, I abbreviate wherever possible. Okay, now I know, right, in Canada, I think they call them postal codes, not zip codes. Okay, so maybe I abbreviate CUST ADDR, CUST, zip. I don't know that writing queries with table name or field names that are this long, they become problematic. Okay, anyway, that's my take on it. But notice that the names closely resemble but don't exactly match. The field names shouldn't have spaces in them. They can, not considered good practice. Okay, so how do we map composite attributes? So in the ER diagram, composite attributes are listed this way. The customer's address is made up of number and street, city, state. Zip code is kept separate. Could zip code or postal code be part of the customer address? Sure. Sure, it could. Okay. I would always, though, even if this is part of this row in your ER diagram, I'm always going to keep that as a separate field, obviously. I can filter by postal code then. If it would make sense to sort by zip code, I'm trying to think of an idea where that would make sense. Like, why would you need to sort by zip code? But having it as a separate field here, obviously lends itself well to that. Okay. We've got multi-valued attributes. So multi-valued attributes in your ER diagram, the pointed brackets instead of the parentheses. Each employee will hopefully bring at least one skill to the table, right? So if I'm a server administrator, my skills should include Windows Server, Active Directory, DNS, DHCP, and 100 other things. Notice the way that the database tables, this is one entity type in the ER diagram, but we're splitting it into two different tables that will be related to one another through the employee ID field. It is important that this be broken out like that. When we get to second and third normal forms, I'm going to show you some pretty specific examples of what happens when you design your tables poorly and you've got multi-valued attributes to take into account. Okay, weak entities, the one I always go to. Every dependent for human resources purposes goes on your medical insurance, right? Taxes, right? For withholding, etc. Every dependent has an employee associated with it. Not every employee has dependents. If you don't have any children or anyone else in your house that is a tax dependent upon you, okay, this means that dependent is a weak entity if for some reason the employee relation was removed. This relation cannot stand on its own. You cannot have dependents without relating them to employees, right? So I hope that makes sense. Okay. Again, how do I relate when I'm building my database tables? Right? Obviously, the employee table is going to have additional information, address, city, state, zip, etc., right? For simplicity's sake, the author just lists the two fields here, ID and name. The dependent table should also include the employee ID. And we're going to relate them, right? Because every employee can have 0 or more dependents. Okay, so it is possible that employee ID shows up in this table more than once. But while employee ID is the primary key of this table, it is part of the composite key of the dependent table, right? So again, I'll explain this and you could tell me, thank you, Captain Obvious. How likely is it that the same employee is going to have two children and name them exactly the same thing? That would make no sense at all. I can't say that that's never happened in human history, but I just can't think of. So first, middle, last, and ID together, composite key, for a table that cannot exist without its parent table. Okay. One-to-many, many-to-many, and one-to-one relationships are mapped next. Now, this one is important. We have looked at some existing ER diagrams where the relationship is one-to-many. Well, how do I determine, right? One student can take many classes, but L-Tri-C has many students, each of whom can take many classes. Why isn't every relationship a many-to-many? Well, the primary key side of this example would be L number in the student table. When I talk about the L number field in the student table, how many rows am I talking about? Just one. Your L number appears in the L-Tri-C database in the student table exactly one time. How many courses can you take? 0 to however many you can take. Okay? And generally, that's how one-to-many relationships are defined, as opposed to me saying, well, many students can take many classes, right? So more details on that a little bit later, okay? So take a look at this mapping, right? So if we replace customer with student and we replace order with course, it's exactly the same thing here, right? One and only one student can take 0 to many courses. One and only one customer can place or submit 0 or more orders. Now, I could, if I wanted to, and I'm not going to hold you to this, can orders exist without customers? Nope. Order could be defined as a weak entity type if you want to think about it that deeply. Okay? If the right side of this relation can't exist without the left side, this becomes a weak entity. Now, this is a silly example, but I'll make it. If this is students and courses, can courses exist without students? Well, yes, not for long, but yes, because over here we've got a professor's table, and the professor's table will be related to the courses table. Now, right, obviously, if every L-Tri-C student left, the school would close, which is why this is a silly example. But, okay, in my case here, where I've got student, course, and professor table, the course table would not be considered a weak entity. Again, I hope that makes sense, but if it doesn't, that's okay. Okay. Many-to-many relationships. You could look at this a couple of different ways. I could say here, one and only one employee can complete 0 to many courses, right? So new employee orientation might include different safety courses, videos you have to watch, right? You have to sit through a human resources presentations on the human resources things, right? How to fill out your paperwork, the don't sexually harass people, right? Blah, blah, blah. There might be courses you have to follow. Here, the author is saying 0 or more employees can complete 0 or more courses. Okay? Again, I'm not going to hold you to when is it really appropriate to do one versus the other. For the purposes of this freshman level class, let's say I would have written this as one and only one. Okay, just because that's the way I'm thinking of putting this database together. Okay, now this date completed field is, or table, it's not actually a table. Okay, this is what relates the employee and the courses tables. This is a separate field that gets filled in. Here it is here. What date was the certificate issued? Okay. It is not a separate table in and of itself. Okay. Hence the dashed line here. The dashed line tells me that this is not a separate table, but this field is what we're using to relate this relation to that one. Okay, one-to-one relationships. Okay, I have one nurse and only one nurse. Can be assigned to, well, I don't know why the author chose optional one here. This is optional one, also known as 0 or 1. So I guess I don't have the business rules in front of me. So I'm just guessing here when I say maybe a specific nurse can be assigned to 0 care centers because that nurse might be a home health nurse. So that nurse might not go to Lehigh Valley, Muhlenberg, or the Lehigh Valley office up here near where I live in Pottsville. Okay, that's what I'm guessing. Okay, but again, without the repository where all the rules are kept, if you would ask me to bet cash money on why is it 0 or 1, okay, I would guess, but I wouldn't bet cash money on it because, right, as I said, okay, and then this field is how one table relates to the other. Okay, we haven't talked about associative entities at all. We'll come back to those. Maybe. Let's see what the rest of the slide deck looks like. And, okay, let's quit right there. Okay, because the next 2 slides do talk about associative entities, and I don't have any examples prepped for you. So we're going to go back here. This is slide number 22, and I'm going to stop right here and wish you all a good evening, and I will talk to you all in the next video.